Max. Today we're going to be talking about insert from Lab 7. Lab 7 dealt with linked lists and trees. So let's look at what a linked list is first. We've got a linked list that's going to have some first, which is some value, and a rest, which is going to point to another linked list or some empty constructor, so some empty list. It's got some interface methods, get item, lets us actually do the sort of the indexing lookup that we can do with lists, some length, and some repr strings so we can actually print it out. Okay, so now let's go to what we're actually implementing. We're asked to implement a function insert that's going to take some linked list, a value, and an index, and is going to insert the value into the link at the given index. You can assume the linked list already has at least one element. Don't return anything, this is important. Insert should simply mutate the list. Alright, so let's take a look at what a linked list looks like. It's got a first, which is some value, and a rest, which points at another linked list. So we know right away, we can sort of see that this is a recursive data structure, right? Every one of our rests is either going to be the end, sort of a base case, which is an empty list, or it's going to point to another set of linked lists. So this in this case is another linked list, right? Okay, and now we're implementing the function insert, which takes this initial list 1, 2, 3, and is going to insert the value 9001 at its 0th index. So this original list is just going to be moved into what it looks like this original list is just moved into link.rest. Okay. All right, so let's look at the actual body of our code. So we're given define insert. It's going to insert some value into a link at the given index. We're given some doc tests. The doc test has link is equal to link 1, 2, 3, which is what I showed. We're going to insert something, and then we're going to get this linked list out. Okay, so if I was doing this, I would sort of take a look and say, well, this looks like it should be done recursively. We know we're dealing with something that's going to be able to, if we define something across links, it's going to work for all of its link.rests, right? So that looks like something that we're going to be able to just make a recursive function for. And let's think about what our base cases are then. So since I know I'm doing this recursively, I can think about some base cases. Okay, so this looks like they're sort of giving us the base cases in this order. So let's first look at our simplest case where we actually insert something is if we're trying to insert something into our 0th indexed item. So let's look at this. So if link, well, so let's think about this. So if index is equal to 0, then what we want to do is, if I'm thinking about this right away, sort of my natural instinct is to do link is equal to, or link.rest is equal to link, and then link.first is equal to the value, right? So let's try this in an interpreter, right? Because what I did, so this is link initially, right? This 1, 2, 3, and all I'm going to do is I'm going to take this one, and I want it to sort of like point back at itself, and then I want to change this value here. Okay, cool. So let's give that a shot, and we can sort of try that in the interpreter and see whether or not that works. Maybe python-i lab06.py. So I'm going to start just doing the doc test that they gave us. We've got link is equal to link 1, 2, 3. Now if I do, let's try this. So if I just wanted to, so I'll just pretend that I'd be passed an insert, or index is equal to 0. So I'm going to do link.rest is equal to link, and then link.first is equal to 9001, and then let's just print what, oh no, we've exceeded our maximum recursion depth. Well, that's sort of weird. That looked like it should work. But here's what happens. So when we actually try and we originally start with this linked list right here, right? And when we do link.rest is equal to link, what we're really doing is we're taking this pointer here that is rest, and we're pointing it back at itself. So we're pointing it back at itself, and then we're changing this value first to 9001. So I'm going to change this value first to 9001. But what's going to happen is I'm just going to continually loop through this first link. So, okay, well, this is sort of a pain. It looks like what I need to do really is to create some sort of new link, right? So I see that here I'm actually making my linked list longer. So it makes sense that somewhere in here I need to make a new link in this linked list chain, right? So here's where we can do that. We can first we know that this new link is going to have to be almost identical to, it should actually be exactly the same as this first link that we originally had. Because all we want to do is add an item onto the beginning of our list. So we want to preserve our original linked list. So linked list 1 is equal to link 1, link 2, and link 3, which is this original list, right? Now I'm going to define some new link, which I'm going to say is link with this constructor, link1.first, which is 1, and link1.rest, which is going to point to the rest of this list. So it's sort of like what we were doing before, where we were sort of pointing back to ourselves, except now we're actually formalizing and creating this new thing that's going to, this new link, which is going to look exactly like our link.first, except we're going to avoid this maximum recursion depth problem. Okay, so now this is almost right. What we need to do now is we need to point our first link to this new link that we've created. So what we do here by doing link1.rest is equal to new link. And now, well, this is almost right, but we needed to actually insert, we needed to change this first value here to be 9001. So we're going to set link1.first is equal to 9001. So remember, this is all also just for our base case. This is if we're adding something, we've gotten to an index equals 0, and we're adding something to the beginning of this new linked list. Okay, so let's give that a try. I'll exit this. Clear, oops, exit clear up here, python-i lab06.py. Okay, so now I'm going to make a new link is equal to link. Actually, I'm just going to copy and paste that. Okay, so I'm making a new linked list right here. I'm going to try my new insert formulation. So I'm going to make this new link here. It's going to be equal to a new link. It's link.first, link.rest. So new link should look exactly like our original link. Okay, it does. That's perfect. So now if I change link.rest equal to new link, I should have made my original link longer, and I have. Now I need to actually go ahead and modify my first element is equal to 9001. Now does link behave? So now this is the exactly what we want to get out of link without if we want to actually like change, if we want to actually insert something into our 0th index, right? So this is what we expect if we wanted to insert 9001 into our 0th index. So this is just our very first base case. The reason we've made this is because it's sort of confusing, right? So it looks like you should be able to just set the link.rest equal to link1, right? And have that essentially do this functionality, right? A lot of people think, okay, well, if I just set link.rest equal to link1, it's going to make some new link, and then I'll be able to continue. What it actually does is this bizarre sort of recursive nightmare problem. So you actually need to make a new link, expand the length of your chain, and then direct yourself to that new link. Okay. Okay, great. So we're still dealing with our base case, so let's put what we implemented in here. We're going to say new link is equal to link link.first, comma link.rest, and now we're going to say link.rest is equal to new link, and link.first is equal to value, just like we had there. Okay, so this is just our base case. This is if we're asked to insert something when index is equal to 0. So now let's look at what else we might have to deal with. Okay, so we might have to deal with something where index is not equal to 0, right? So if we need to implement something into our, put something into our second index, what we want to do is, now what we can do is else, we can say, all we need to do is call insert on the second set of our, on our link.rest, right? So link.rest, and we want to insert the same value. But now we want to, since we're actually looking at the rest of the link, we want to insert it into index -1. So here, if I'm trying to insert something into my first index, if I'm asked to insert something into my first index of this link, and link is defined as 1, 2, and 3, what I really want to do is insert something into the 0th index of the rest of my list, right? So if I want to put the value 9001 right here, it's like I'm inserting into the 0th index of the rest of my list right here. Okay, so that makes sense. We're going to insert link.rest value index minus equals 1. And then now we have one other check we need to do. If we're trying to insert into something that doesn't have an index that can accommodate that insert, we should print something and exit the function. Okay, so now we can make a pretty easy check of that. Since we have the length function here, check if the length of our list minus 1 is less than our index. Then we want to print index out of bounds, and we want to return out of that list, or return out of this method. Okay. Let's give this a shot. Alright, now let's see if something actually changed when we did this. We want to say link is equal to link 1, link 2, link 3. And now we insert something into it. Let's see if link is different. Great, so we've successfully inserted something into our 0th index. Now let's see if we were able to successfully insert into the 2nd index. Link now should be equal to, yeah, this is exactly right. So this is our 0th, this is our 1st. Now our 2nd index has the value of 100. And now let's see whether or not this index out of bounds works. Perfect, we're getting out of bounds. Okay. So this is a complicated idea. Just a quick recap of what we did. We started with a linked list. We ran into the problem, we wanted to implement something that inserted something into the beginning of our linked list, just as to handle our base case. And we ran into this problem, which was super common for a lot of people, defining a linked list, and then wanting to essentially put a copy of that linked list as the rest of link 1, but instead doing a infinite recursion. This is a very common problem that people had in this lab. Infinite recursion right here, and then trying to reset link 1.first, and then this just not working, right? Instead, what we did is we created a copy by using this link 1.first, link 1.rest, and then we pointed to that from our original link head, and then we changed the value of our link head, and so now we were able to actually append to our list. And the recursion is pretty straightforward, right? If we wanted to insert something into an index that was greater than 0, we just needed to insert something into index minus 1 of the rest of our list, right? And we handle out of bounds exceptions. One other thing to note is that we're not returning anything in this function, right? It's important to note that the insertion method is actually just a mutation method and is not going to actually return the value of link. So, yeah, if you have any questions about this was a tricky problem, and feel free to post on Piazza in the comments, and I'll help you out with it. Okay.